Hi everyone, I am here with one interesting topic based on prime numbers and factorial. So what is the relationship between prime number and factorial of a number? So according to Wilson's theorem, there is strong relationship between prime number and its factorial. For example, if n is a prime, then n minus 1 factorial plus 1 is divisible by n. So this is the fact. So what is the relationship between prime and factorial? If n is said to be a prime, then n minus 1 factorial plus 1 should be exactly divisible by n. For example, if I need to say 5 is a prime number, then what is the relationship between prime number and its factorial? Then 4 factorial plus 1 must be exactly divisible by 5. So let us check this one. What is 4 factorial? 4 factorial is nothing but 24. 24 plus 1 equal to 25. It is exactly divisible by 5. Exactly means the remainder will be 0. So in the algorithmic terminology, we can state this like, if 1 plus factorial of n minus 1 percent n, what is this percent? This is nothing but modulo division symbol. If it is equal to 0, then n is prime, otherwise n is not prime. Okay, so let us quickly go through the Python code. I already wrote Python code for this. So Wilson's theorem states that if factorial of n minus 1 plus 1 is exactly divisible by n, then return true, otherwise false. So let us have a look at this one. We all know that in math library or math module, there is one function by name factorial. We need not write code for this factorial in Python. This is readily available in the math module. Let us use that one. So I am writing one function def is prime of n. That means if n is prime, my function should return true, otherwise false. So that is the logic here. If math.factorial of n minus 1, that means it will find factorial of n minus 1 plus 1 is exactly divisible by n. Exactly divisible in the sense the modular division must return the value 0. Return true, otherwise false. So for example, if we run this code for input 5 is prime of 5, we must get the answer true. Okay, let us quickly check this one through Python code. The Python code is written like this. We have already discussed how it will work. Now let me run this code. So what is the answer we got? True. Okay. Let me change the number. Let me give this as 10. Let me run the code again. What is the answer we got? False. Okay. Let me give some 97. It is a prime number. We must get true. Yes, it is working perfect. What is the time complexity of this code? The time complexity of this code is big O of n. Why? Because we are finding factorial. So what is the time complexity to find factorial of a number? Big O of n. So that's why for this method or for this function, the time complexity is big O of n. Okay. I hope you understood the logic. Of course, this is not the efficient method when compared to our square root approach. Even then, this is like a very interesting relationship between prime number and factorial. Okay, I hope you understood the logic presented here. If you have understood, hit like button, share it with your friends and subscribe. Thank you.